Here's a really good application for logarithmic and exponential functions. Go to the bank and invest $300. It's compounded monthly, which means that we're going to be using the compound interest formula. And then how long, so we're going to be solving for t, and if we're going to be solving for an exponent, that means we need to use logarithms. That's the whole job of logarithms, is to tell you what exponent to use. So that means for everything else we must have numerical information. So the initial investment is the principal, 300. The interest rate is 4%. Use the decimal form, 0.04. Compounded monthly means that n is a 12 for 12 months in a year. And then solve for t so that we end up with $2,000. So I've got a base raised to an exponent, and I need to solve for the exponent. The first thing to do is isolate the base. Divide both sides by 300. So if you divide by 300 on both sides, you can have it reduce a little bit so that we've got a 20 over 3. And again, on these problems, don't use a decimal approximation, use the exact value. And even in the parentheses, I'm just going to use the whole thing, not simplified, but exactly as it is. That will give us the most accurate result in the end. Now the next thing that we can do in order to get this exponent down in front of the base is take natural log of both sides. So do the same thing to both sides, and now we can use one of the rules for logarithms, that this exponent of 12t can be brought down in front and multiplied with the logarithm. And this side is still the natural log of a fraction. Okay, now we've got an algebra problem, or should I say an algebra fun. To solve for t, we need to divide by 12 and divide by this logarithm. So divide both sides by all of that. So it's going to be one big fraction where this is the numerator, the natural log of a 20 over 3. And the 12 and this natural log are going to be divided, so they become the denominator. 12 and the natural log of 1 plus a 0.04 divided by 12. All right, now we're ready to use the calculator and find out how much that is. And type the whole thing in at once. So start with the natural log of 20 divided by 3, and then that needs to be divided by, and because it's more than one thing, I need to use parentheses for this denominator. Tell the calculator, here's the denominator. It's got a 12 and a natural log of 1 plus 0.04 divided by 12. And now we need that parenthesis to stop the natural log. And we need another parenthesis to stop the fraction. And the whole thing is equal to 47. So t is equal to 47.507, which is saying if you invest $300 at a mere 4% compounded monthly, how long will it be until it's worth $2,000? It's going to take about 47.5 years. Another way to look at this is in the United States, inflation averages around 4%. So if you're wondering, hey, if I've got $300 now, what is the equivalent amount 47.5 years from now? So whatever I can buy with $300 now, well, in 47.5 years, it's going to take $2,000 to buy the same stuff. Pretty interesting.